Hi, we're back again. Bit more of an update with our PJ5 CPU. We've got what we've christened a fake ROM board down here. This is a TNZ with some level converters that's interpreting program counters and spitting out various instructions so that we can test all the various bits. So we've written a very simple program which we'll show you running in a second. What we do is we jump to address 0002. I'll explain why in a moment or two. Then we clear all the registers one at a time, and then we do 3 NOPs. Then we load register F with a value of 2, register G with a value of 101, and register H with a value of FF. All become clear. Then we multiply register F and register G, and we store it in register D. Then we multiply register F with register H, and we store that in register E. We then use our funky command where we can jump to the value held in 2 registers. When then we jump to that, we then copy the value in register F into register A, and then we do a halt. So we can't do a lot of things like conditional branches and stuff because the register board, special register board, sorry, that sits up here is missing. But this tests everything that we can do now. So I will flick this over to run. I've got it running at slow clock speed so you can see things happening. So we're off into run. We jump straight to 2 and we start clearing the registers. Remember, everything's running on 1 instruction per cycle. So this is the clock down here. You can see we're clearing the registers. Pause, hold your breath. So now we do 3 NOPs, which you can see here. Now we load the registers up here. There we go. We're going to load register up there with 2, then 101, and then FF. Then we do the multiply, store it in D. Next multiply, store it in E. Then we jump, which gives us our nice little cafe. Copy a register, and we stop. So that's all the functions that we have at the moment. There is one other command which we have implemented, which I will show you in a moment. So what I'm going to do now is show you our interrupt function, and this is why the program starts at 0 and immediately jumps to address 2. When an interrupt happens, it jumps to address 1, which you'll see happen down here. So what we've got is when you get an interrupt, it jumps to the interrupt, it sets register B to 1, 2 in hex, register C, which is this one, to 3, 4 in hex, and then we do a return I, and then we carry on with the program. So I've slowed the clock down. I'm now going to restart the program and I'm going to press interrupt probably when I get to about instructions 4 or 5. So let's give this a go. Oops, press the reset button. So I'm going to do it now. You'll see the interrupts happened. We've jumped to 1. We've gone to our interrupt address, loaded the values, we've returned from the interrupt, and we're carrying on clearing. And the rest of our program's running, so there's the 3 NOPs. Now we're doing the loads and the multiplies, and then we jump to cafe again, do the copy, and we stop. So we have interrupts running, ret I, and all the other jumps, basic jumps and things. We only have 1 instruction that takes 2 clock cycles, which is the ret I. Unfortunately, there was no way around that. It's kind of frustrating, but it does work, so we're happy. So I'm going to try and speed it up again a bit more. Let's do a reset, so that's it running normally. I'm going to try and catch it before it jumps to cafe. Reset. There we go. So you can see it did it very quickly. I'll do that again. There you go. And a normal run, you can see it clears the registers, does the multiplies, and doesn't touch these 2. Do a run. Press the interrupt, registers are set, and then it does everything else. So we have fully working interrupts, program counters, jumps, the instruction decode so far with a couple of mod wires is running, and the main register board's working. The multiply is working really well, super happy about that, and the clock board's working. So yeah, things are looking really good. Thank you.